Hello everyone, welcome to this video. In this video, we shall see question from December 2015 consisting of 3 marks from abstract algebra. The question says which of the following is an irreducible factor of x to the power 12 minus 1 over the field of rationals, right? So you are given these 4 factors. You have to suggest which of these are irreducible as well as a factor of this polynomial x to the power 12 minus 1. So we have 2 methods to solve this question. In first method, we shall see a very simple technique, that is we'll factorize this polynomial x to the power 12 minus 1. Right? How can we do that? You can write x to the power 12 as x to the power 6 raised to power 2. That means this thing squared, x to the power 6 squared minus 1 squared, right? And now we can apply this formula. A square minus b square is equal to a plus b and a minus b, right? So this comes out to be x to the power 6 minus 1, x to the power 6 plus 1, right? Again, you can write this factor as x cube squared minus 1 square, right? And if you write the same for this factor, it won't work because we do not have any formula for a square plus b square, right? There is no such formula. So here what we have to do, we have to write in form of cube. So we can write this as x square raised to power 3 plus 1 cube, right? So here we can apply this formula, a cube plus b cube, right? So what is this? This is equal to a plus b into a square minus ab plus b square. So this thing is equivalent to x square plus 1 into the square of this minus this term multiplied by this term, that is x square, plus the square of this, that is 1 square, and x square plus 1 as such. And this on factorization give us x cube minus 1 and x cube plus 1 according to this formula, right? So now we can again factorize this according to this formula. We can write 1 as 1 cube, right? No problem in that. So it would be x minus 1 into x square plus 1, and then again we can apply the formula of a cube plus b cube. So we can write 1 as 1 cube. So this thing would turn out to be this x plus 1 into x square minus x plus 1, and then this factor as such, and then this factor as such. So now can you see, can we factorize it again? No, we cannot further factorize this, right? So from here you see that every factor is of either of the degree 1 as in this, or of degree 2 as in these, or of degree 4, right? And let us have a look at our options. So here we have degree 8, 4, 4 and 5, and of degree 4 we have this. So C is the correct option as for this method, right? So this is the irreducible factor of this polynomial, right? So now suppose at some step you are stuck that what should be next. For example, if you have started, instead of writing this polynomial as x raised to power 6 raised to power square minus 1 square, you could have written it like this, x to the power 4 cube minus 1 cube. In that case you might stuck, right? And you might not be able to get all the irreducible factors for this polynomial. So this is the most simplest method, but suppose in exam you get stuck somewhere else. So we have this second method using the cyclotomic polynomials. Now in this we'll use some results from cyclotomic polynomials. It says that any polynomial of this form, x raised to power n minus 1, could be written as the product of some cyclotomic polynomials of where this d is a divisor of the given n. So we have here n as 12. So d divides n gives you 1 divides 12, 2 divides 12, 3 divides 12, 4 divides 12, 5 divides 12 and 12 divides 12. So we have the value of d as these. So therefore this whole factor gives you the product of these cyclotomic polynomials. So now now that means we get 1, 2, 3, 4, 5 and 6 factors for this polynomial, like in this case. So now we need to check what is the degree of each of these cyclotomic polynomials. So there is second result, degree of this cyclotomic polynomial phi n of x is equal to phi of n, where what is this phi? This is the Euler phi function, right? And it gives you the number of positive divisors of n, right? For more details about this Euler phi function and the cyclotomic polynomials, you can have a look at the video number 19 from the playlist Field Theory, the link of which is given in the description, right? So now we have this with us, phi 1 of x, phi 2 of x, phi 3 of x, phi 4 of x, phi 6 of x and phi 12 of x. So the degree of phi 1 of x would be this phi of 1, and phi of 1 is basically 1. So basically you are looking for all the divisors of 1 which are relatively prime to 1. So here in case of 1 we have only 1, so the number would be 1. For 2 we have the divisors of 2. All the divisors of 2 are 1 and 2. But you see 2, the GCD of 2 with 2, that is equal to 2 and it is not equal to 1. And we need all those numbers whose GCD with 2 is 1. Right? So this 2 is not taken. So the only number is 1. So we have 1 in total. Degree of phi 3x. So all the divisors of all the numbers less than 3 which are relatively prime to 3, they are only 1 and 2 because 3 is not relatively prime to 3. And the GCD of 1 with 3 is 1. GCD of 2 with 3 is 1. Therefore, in total we have 2 numbers, right? Therefore, this phi of 3 is 2. Again, degree of phi 4x, it is the numbers less than 4 which are relatively prime to p. That means we only have 1 and 3 because 2 divides 4, and the GCD of 2 with 4, that is equal to 2 and not equal to 1, and the GCD of 4 with 4, that is again equal to 4 and not equal to 1. Therefore, we have only 1 and 3, so 2 in total. So this is 2. Then the degree of phi 6x, that is 2, similarly counted. The numbers are 1 and 5 whose GCD with 6 is equal to 1. And for phi 12x we have 4. The degree of this polynomial is 4 because the only numbers are 1, 5, 7 and 11. And the rest other numbers, that is 2, 3, 4, 6, 8, 9 and 12. They all have GCD with 12 which is not equal to 1. So these numbers are not taken. So from here you see that every polynomial phi 1, phi 2, phi 3, phi 4, phi 6, they have either degree 1 or degree 2, right? And this phi 12 has degree 4. So now you see in the option, we do not have any polynomial for degree 8. We do not have any polynomial with degree 5. We have polynomial with degree 4. So these would be the two possible options. And both of these are irreducible as well. So now to see whether they are factors of this polynomial or not, you could just see whether this factor divides the polynomial or not. In this case, this does not. And the third option, it divides the polynomial x to the power 12 minus 1 completely. Therefore, this is the correct option. Although this method is, the second method is a bit lengthier than the first one, but this is required when you are unable to solve this very simple question using the first method, right? So that you do not lose your marks, 3 marks for this very easy question. So the correct option in this case is C, because option B does not factorize x12 minus 1. So the correct option is C. Well, that is it for this video. Thank you for watching.